and this is kind of a little activity. So the activity is you have to think about a building. So currently you are now also in a building, a lecture hall. Just think about a building or a space you still remember like a very good building. You don't need to remember the name of the building, but how you felt in that space and what are the features that made it memorable to you. So I will point out few of you and just give me an answer why you are interested in that space. Okay, to support that, I will. This is one space I would suggest what I am talking about. Have you ever been to this kind of space? It doesn't need to be a lecture hall or any type of building, any type of space. Okay, how about you? Any building that is memorable to you? What's your name? The black t-shirt. Okay, any building you can remember? No. How about this lecture, this university, some space? Even I could feel some. This will be memorable space for me also. So how about you? Okay, let's ask this side. The second one, you. Any building you remember? NSBM. Okay. So what made it memorable? Why are you interested in that building? Maybe there are a lot of greenery, or what are the reasons? Okay, so that's fine. You will realize why I am asking this question, and let's see. Okay, I'll uh, I'll play this video. This is a short video. This is a this is the built environment in Singapore. So you will see how this this is, we call this is sustainable built environment, and let's see how it looks.
Place creates gardens and parks in the middle of its buildings. That's because in parts of Singapore, you're required to replace the land that you're building on with this same amount of greenery. So the greenery that is lost on the ground is replaced in the sky. Each building must have greenery that's equivalent to at least 100% of the land that it was built on. But some take it to the next level. Its building has over 200% greenery for the land that it replaced. This is Park Royal, and it's absolutely crazy how they managed to include greenery throughout the building. You can even go on a garden walk here. But all of this is not just done for a more beautiful look. There is a functional reason as well. See, buildings with more greenery end up using less electricity, produce less waste, and in general have a lower carbon footprint. You also improve the air quality and keep the temperatures cooler. This rooftop is over 50 stories high, and it's pretty much entirely a garden. And the crazy part is that it's completely open to the public. This is a public.
Okay, so you saw this is not only about greenery, but greenery plays a major role, and you saw how it looks like, or how it. You may also feel something about the built environment. It is really interesting, really interesting to live in that kind of space, right? So the Park Royal building that was talking about in the video was this. This is a building in Singapore, a hotel, and in Singapore there are many types of such buildings, and it is mandated to replace the built area, like the land area, with the greenery space, even though there's a building. So that's what it said in the video. So this is still the introduction. Don't worry, we will be talking in detail about these principles. So I asked you what made it memorable in a space. So these might be the reasons that if you are living in a space, but you may not remember at the moment. But just imagine a space where we get the natural light and we can see the outdoor spaces with a lot of greenery, and uh, at the second image there are a lot of greenery involvement is there. and you can feel the wind blowing. The natural ventilation is felt rather than the AC. And if there's a building with a lot of smart features where like motion sensors, when you enter into a space, buildings. So what is a green building? This is this is one of the definitions given by the World Green Building Council, WGBC, World Green Building Council. So accordingly, a building that reduces the negative impact and can create the positive impacts on our climate and natural environment, all in the design stage, construction stage, as well as the operation stage. And also it preserves, if that preserves the precious natural resources as well as improve our quality of life, then we call it is a green building. So what are the key items you have to remember? If okay, only one. Okay, let's see what's the answer. People, planet, profit, triple P. Yeah, people, planet, profit. Also we call people, social, then planet, environment, and profit means economy. That means if something is sustainable, we have to balance all these three components. So uh, let's say building, if a building is sustainable, it reduces the utility bills. That means it eliminates the carbon emission to the environment. Then it is good for the planet, environment component. Then and the quality of life means it is good for, at the end of the day, it is good for the pocket, right? Then it supports this profit, the economic component. So that's how a green building supports the sustainability. So it's, is it clear what? Okay, let's so if I ask a question, if it is clear, just at least give me a thumbs up or show me that you are awake. Okay, otherwise it's boring to conduct the lecture. Okay, so green building concept is actually not a new one, especially in a country like Sri Lanka and in the uh, south in a country like Sri Lanka, we thousands years ago, from the ancient time, we built with like with the support of nature. Like we didn't we lived with nature. We constructed our buildings and spaces so that we, without forgetting our natural environment. So like you may have heard the Vastu Shastra, right? So those are not just like ancient principles, but it has a meaning. So there are 5 components in Vastu Shastra: air, fire, water, earth, and ether. So the spaces are designed. Spaces are allocated in a design of a building, so that these components are allocated in a proper way. So, like we consider the wind direction and how the sun path, and all these things are considered when we allocate spaces in a house, basically. So you see, uh, so we avoid septic tanks and all the things in northern eastern area. So that's one example why we avoid that according to Vastu Shastra, because the wind direction is uh, the wind direction in Sri Lanka is in northeast to southwest, right? So when the wind comes to this direction, if the septic tank is in that uh, northeast, then what happens? All the germs comes inside the space. So that is not good for the health inside the uh, that is not good for the health of the occupants inside the building. So that's why, according to Vastu Shastra, we avoid that, avoid having that septic tanks or in northern east side. So all the principles have that type of scientific background. So we the green building principles are not new. Okay, so let's see in the current context, how does a green building look like? So any to construct a building, we need so many things, right? We need materials, we need energy, also we need water. Those are the basic 3 items. And then we go into a life cycle. So when we say a building, we don't just look at the operation stage or just the construction stage. We have to consider the entire life cycle from the raw material extraction. So let's see a brick. Even though there's a brick, to construct, to have that brick, there's a separate process, right? Like extraction of the raw material and manufacture it into a brick. There's an energy behind that. There's an energy embedded in that. So likewise, raw material extraction, manufacturing, then transportation, then we do the construction on a site, and then comes the use stage. Then we have the refurbishments done, all the maintenance stuff, and then after the life cycle, we have to demolish the building and disposal. So this is the building life cycle. When we look at the green buildings, we have to have understanding about all the whole life cycle. And so yeah, there are inputs as well as there's a process or the build. So water that we are utilizing in the space, and we can enhance the indoor air quality so that the health and well-being of the occupants are taken care, and we are using the land, and the landscaping are utilized for the benefit of the building and the occupants. And also we minimize the life cycle effect from the building. before moving ahead? Are you clear what why we are talking about green buildings? Okay, that question will be answered in this section. Why sustainable built environment matters. Before that, there's a 2-minute video again. Let's watch and continue.
We spend 90% of our lives indoors, but the buildings in which we live, work, and play have become a big part of the problem of climate change, accounting for 39% of the world's energy related CO2 emissions. That is more than all global transport emissions combined. 11% of these emissions are attributed to buildings before we even step inside them, through the manufacturing and transport of materials and our construction process. So, how do we reduce these carbon emissions from the built environment? It's about addressing the entire building life cycle. A building's carbon footprint is intertwined with all stages of its existence, from design and
Last
construction
question.
to building use, recycling, and demolition. For example, building design can integrate green spaces for trees to absorb CO2 or on site renewable sources like solar panels. Building use accounts for 28% of global energy related carbon emissions, most of it from heating, cooling, and lighting. But the impact of buildings carries on even after they're gone through the environmental impacts of deconstruction. At the same time, buildings can be repurposed, recycled, and upcycled into green buildings of the future. Today, 91% of us breathe polluted air on a daily basis, air that fails to meet World Health Organization guidelines for pollutant exposure. As we face the challenges of COVID-19, healthy and sustainable buildings have become more important than ever before. Through a united effort in following new building strategies, environmental impact can be reduced to build a better future.
Okay, so why sustainable built environment is important? Why are we talking about green buildings? So this has few answers in it. So what is the percentage of you living inside a building? This says 90% of our time, but how about you? Sometimes with this nature, with this weather and all, sometimes 100% of our time we live inside buildings, right? So if the building is designed in a very unhealthy manner, then it impacts on our health. So just imagine now it's fine, you are in lecture halls and then lecture to lecture sometimes you will change the space, but just imagine if you are living in a office building. I am speaking with my experience. I had some uh, like unhealthy buildings I had to work in. So if we are living inside that type of spaces are given, then we have to, whether we like it or not, we have to stay in that space for like 7 to 8 hours per day for like 5 days a week or something like that. Like major component or major part of our day is in the building. And if it is unhealthy, it impacts on our mental health, physical health, and then it's a disaster. So that is why building a space, whether we certify the building or not, we have to follow the principles, the green building principles, to make that building a healthy one. So the scale of the problem, now we are talking about the scale of the problem, why built environment is important. So globally, 37 to 38% of the global carbon emission is from the building. And from that, 11% is it's really important to make those buildings sustainable. So like I said, we have to balance all the three pillars if it is a sustainable or green building. Then rising to report their businesses impact on the environment as well as the environmental impact on the business in their financial reporting. So that means they have to calculate the carbon footprint of their operations and how they cause damage to the environment. Likewise, they have to do the risk analysis. So that's a legal requirement, and it is getting mandatory by 2030. All the businesses have to do that reporting. So that's why investors are now have a major focus on their investment, how where their money goes, and they have to ensure that it doesn't do any harm to the environment. So green building principles are now becoming more and more important. So we are still identifying the scale of the problem, and like I said, the rating systems are getting updated because the carbon emission calculation inside the buildings are getting mandatory actually with all these regulations upcoming. Now we have to showcase the carbon emission caused by the building. We have to calculate. So in that case, we have to show it in two parts: embodied carbon emission and operational carbon emission. Embodied means, like I said, using the example of a brick, to construct a brick also we have to burn it and we have to do some processing, which energy is involved and all. We have to calculate that emission cost to construct, to manufacture those raw materials as well. And you can see in this diagram how that emission is also divided into the different stages. So accordingly, A1 to A3, until the raw materials that we are using, it causes like 42% of the emissions is materials, the embodied emission. Then nearly 50%, like 47% of the carbon emission of a building is caused by the U stage, like B6. And then the construction is just 2.2%. Then transportation, replacement and refurbishment, and end of life, those are the rest of the parts. But the major ones, materials and the usage, energy consumption. Okay, so now you can see where the problem is. And if we say a building where the most impact to the environment is visible from this, because the carbon, in terms of carbon emission, the major carbon emission is caused by the usage as well as the material manufacturing. Okay, now let's discuss a bit about the history, but I know you might not see the all the wordings. I added this so that the reference, uh, but if I explain it, like ancient times, we used the Vastu Shastra and all the ancient principles, and we lived harmony with nature. But with the industrial revolution, we started using a lot of energy, and all the buildings started becoming very like mechanical, right? Then at some point around 1970, we realized that buildings are consuming a lot of energy and it causes a harm to the environment. And in around 1980 or 1990, then that's where we started discussing about sustainable development. So with that, we had a focus on green buildings as well. So we started focusing on um, rather than energy, we had a focus on water, materials, and indoor environmental quality as well. And after 2000, there are a lot of rating systems. All the major rating systems were developed around after 2000, and then it's now it is becoming kind of mandatory, and the major principles that we have to follow in construction processes and beyond. The currently and to, like today and beyond, we are talking about AI integration in the buildings and all the smart building features, net zero commitments, net positive. All these things are involved in designing and operating buildings. And the climate commitments, and especially in the construction sector, now the Paris Agreement was signed in 2015, and we have set targets like 17 goals to be achieved by 2030, and now we are in 2026, but still way like behind the targets. And according to Paris Agreement, we set targets to limit the emission or the temperature increment well below 2, but uh, without without ensuring not to increase the temperature beyond 2 degree from the compared to pre-industrial level, but ideally we wanted to keep it below 1.5, but now it has already passed 1.5, unfortunately. So, and we have set according with the Paris Agreement, we have set targets for net zero, like almost all the industries. Building, the building related organization that we have is the World Green Building Council. Accordingly, they have a global project called Advancing Net Zero. So ideally, what it is, I'll discuss about this later in the global trends part. But in the buildings also, we have set target to become net zero by 2050. Um, Again, Green Building Council, World Green Building Council has introduced global policy principles, like 7 principles that we have to use by that's for policy development for different countries. We have to base on these principles, these 7 principles. All the rating systems have to follow this. And advance in net zero, that is that the net zero project launched by World Green Building Council. And SBTI target, science based initiative, is also there. uh, they have they also have a certain standards to become net zero, and net zero businesses, net zero buildings. So likewise, there are a lot of things happening in the world. Okay, so now we are moving into green building rating system. So now we discuss what are the green buildings and what are the green building features, and what are these green building rating systems. So rating systems means it's kind of a document. Document means a guidance document, and it embedded key principles in about green buildings. And like I said, this is a guiding framework, as well as it set performance benchmarks. For example, in a building, the green building rating system say for ideally in a faucet, you can't exceed like 6 liters per minute or something like that. They have a threshold to operate in buildings. So there are performance benchmarks, and they encourage best practices. It introduces these are the best practices, and if you engage these principles, you get this kind of points. So this is a rating system. It gives rating. Then if a building gets a certificate, like it gets verified and take the certificate, then it is a verification. It is good for verification and accountability. You just can't, everyone can say yes, this is a green building and this has a green wall. Just having a green wall, can we say it is a green building? Can we? If you there are buildings and you can see like there are a lot of greenery outside the building, but by looking at only the greenery, can we say that it is a green building? No, right? Because we need to ensure a lot of different aspects, not only the greenery. How about the energy efficiency? How about the water? And what are the materials that it has used? So likewise, we have to see a lot of aspects. But if the same building has a, they have displayed and they are saying the certificate, we are LEED gold certified, we are green SL platinum certified, like that. If we have, if they have that type of certification, then we can ensure that this space is a truly a green building. So, and market recognition again. So green rating system supports market recognition as well, because if the building is certified as a green building, then the property value of that building also increases. Okay, we introduced the green rating system, so let's see what are the different green building rating systems available all around the world. And before that, what exactly is a green building, like green building rating system? So before that, have you like referred or heard about the green rating systems? Have you been to green building? Like, okay, that's fine. So green rating system is it's a structured framework that's for basic three parts, like for measuring and then certify and communicate. So there are different components in the rating system, like a framework. And if a building obtain or the complete that task, they get points. And also there are mandatory provisions, like if they are going for a certification, the mandatory provisions, they have to ensure that the building has it definitely, like it's a mandatory. And there are certain components like credits. Then if they complete that, they get certain points. So if they at the whole point in the framework, they get certain number. So accordingly, they can be certified. Generally, most of the buildings has these thresholds or certification tiers: certified, silver, gold, platinum. Some rating systems, they use the star system, like 1 star, 2 star, 5 star, like that. And but LEED and green SL, they use the tiers like this: certified, silver, gold, platinum. And the green rating system is not only for like building construction. So they have different rating systems for different purposes. For building design and construction, they have one. And existing buildings, if they are converting a building, existing building to a green building, then there's a separate rating system. And for cities, interior spaces, the neighborhoods, all these type of buildings, they have separate rating systems. And also, like I said, there are different rating systems and in different countries. But The major ones are the energy, water, material, or those are the major sections like all the rating systems have. But how about the points? Let's say there are 5 categories and their total points allocated is 100. Does it mean that each section has 20 points, like 20 multiplied by 500? No, they have weighted it in different ways. Most of the rating systems, they have a major focus on the energy part. So they have allocated the major component or major number of certain number of points to energy. So in a country like Sri Lanka, we that depends on the challenges that that region is facing. So energy is a global issue, right? Energy, we use a lot of fossil fuels involved in the energy generation. So we need to reduce the energy consumption in building. So if it is a green building, so we have to ensure that the energy consumption is minimal, like fossil fuel based energy consumption is minimized. So to motivate that, the rating systems have allocated major component or major number of points to energy, so that with the by practicing the components in the energy part, they get more points, right? So in Sri Lanka also, we are very challenging in the land space. We have very limited we have very limited number of spaces available. So land use is we have allocated certain number, or like 25, like 25% of the rating system is for land or site management. Okay, so these are the different rating systems available worldwide, and you can see the World Green Building Council is the like that's a global network. All the green building councils are under World Green Building Council. It's now, by now it's like over 80 countries have the Green Building Councils, and Sri Lanka also has one, Green Building Council of Sri Lanka. And the first rating system was developed in 1990. That's the BREEAM in UK, and the second one around 2000. That was that's the LEED, and this is, those two are like internationally applied rating systems, especially LEED. BREEAM is actually Europe. Europe, lot of Europe countries use the rating system, but LEED, even in Sri Lanka, there are buildings that LEED certified. But then after 2000 and after 2015, a lot of countries developed using the globally available rating tools. Referring to those, they made adjustments and they use their own ratings. They developed their own rating systems because the challenges faced by different countries are different. Like for example, Australian green rating system is Green Star, and Singapore has Green Mark, and likewise, and Sri Lanka has green nestle rating system. India has different, like there are several rating systems they use. GRIHA and IGBC is the Indian Green Building Council. They have a separate rating system. And again, those countries also, that's not only for the new construction, they also have separate rating tools for existing buildings, for cities, sometimes for schools, hotels. They have separate rating tools. So, but there's a major rating tool is for new construction. And the rest of the lecture today, uh, also I will focus on the new construction related rating tool to explain the features in the rating tool. Okay, so this is the evolution of the rating systems all around the world. Like I said, 1990, the BREEAM rating system was introduced, and then around 2000, sorry, yes, 2000, 1998 and 2000, the LEED came up, and after um actually after 2015, a lot of rating systems started developing after 2000, 2005. There are a lot of rating systems came up, and nowadays with the after signing the Paris Agreement, we now have the focus to support sustainable development goals. Some rating tools align their rating tool according to the SDGs. Like I will show you the green mark. They have the rating tool aligned with the sustainable development goals. And with the COVID, we realized that how healthy buildings are important. So now when the rating tools are upgraded, now we have a major focus on how healthy a building is. Like indoor environmental quality has a major attention. And now there's a separate rating tool is also developed called Well Building Standard, Well, WELL. So that's from the US Green Building Council. So that's basically for people inside that focuses on the health aspect of the building. And these days now after 2024 2025, now the major focus is becoming for the global trend AI and smart building, circularity. Those are the mainstreams in the rating tools. Okay, I added this slide, but you can't, I know you can't see, but leisurely go and study. And you can just search and get the clear one also. If you want, I can share the PDF of this one. This research by the Hamza and Young. They have compared the different rating tools available, like 14 to 15 rating systems. And you can see they have categorized it into different parts, like 5 major parts. There are nature component, then human society component, then building systems and infrastructure. So they have compared the rating tools, and the outcome is the green rating systems. Not they just not only assess the energy, but has the all the major focuses, like I mentioned, energy, water, materials, all the things. And different systems prioritize different regional needs. Like I said, we have different challenges, but still energy efficiency remains a major global priority, because energy is a common issue for everyone, and we felt it very well recently, right? Still facing. Okay, modern systems increasingly focus on well-being and indoor environmental quality. And so, like I said, they provide the sustainability benchmark using a rating tool. It becomes a benchmark. Okay, now we will discuss one by one how different rating systems are. The lead is the most popular one, I would say. Lead means the leadership in energy and environmental design, and this was introduced and developed by the US Green Building Council, USGBC. So this is their rating system, but we are applying it globally. And these are the major criterias in LEED. So you can see location and transport, the sustainable sites, water efficiency, energy and atmosphere, materials and resources, and waste management, indoor environmental quality. So likewise, there are several categories. And so LEED has separate rating systems. So this is the different categories. For new construction, they have ID. The BD plus C means building design and construction. Then ID plus C, interior design and construction. They have a separate rating system. O plus M means the building operation and maintenance. They have a separate rating system for neighborhood development. Neighborhoods, when we say neighborhoods, it's not, I think it's not that applicable for Sri Lanka, but they have neighborhood developments as well, and the separate rating systems for homes. And now LEED has upgraded. LEED has revised their rating system to version 5. They launched it very recently, I think end of last year or beginning of this year. And these are the credentials that the professionals can uh, work along these rating tools. So like almost all the rating systems in the world, they have a career path also, like green professionals. Green building professionals are the ones who lead this. So they are the ones who guide this. So if you master that, you can get lead green associate. Then they have separate accreditation pathway for different rating tools. So lead AP BD plus C, lead AP ID plus C. Likewise, there are separate uh, like credentials for each rating tool. So that means lead AP BD plus C means they are accredited to use and like provide the consultancy, I would say, for the BD plus C, building design and construction. And green building, I didn't add that here, but in Green Building Council of Sri Lanka, our local system also has this type of pathway, but not like many, just two: Green SL Associate and Green SL Accredited Professional. Okay, so version 5, the latest version of lead rating system, they have a major focus on mainly like impact categories, I would say. uh, Three areas. The first one is the decarbonization, like 50% of the rating tool is based on that. The quality of life has 25%. So they have a many focus on how a building is designed for people, like healthy building. Then ecological conservation and restoration part, they have like 25% as allocated for that impact category. Okay, again, I don't, can you see? Can you read? No, but you can refer this later. So this is the scorecard. We call this scorecard, and all the rating systems has this type of scorecard. That's the summary of the rating system, right? And it states what are the elements in the rating tool, especially sorry major areas. What are the criteria in the rating system? And below that you can see IPP1. That means that's IPP and IPC. So IPP means it's prerequisite. It's mandatory to have those IPP items in the to get points under this section, like integrate, let's say integrative processing planning and assessment. So you have to have the first 4 items like IPP sections to get the next points. Otherwise you can't try, you have to eliminate the entire section. If you eliminate having, let's say, carbon assessment, if you haven't done that, you can't, even if you have done the integrative design process, you can't get that 1 point, because they are mandatory provisions, like prerequisites. So likewise, this is lead rating system, and totally there we can collect 110 points, but we don't need to collect all the points. But it's mandatory to, if you are certified into lead or whatever it is, whatever required, it says, if it says required, you have to have that. Those are the mandatory provisions in rating systems. We will discuss this in detail. Okay, so like I said, this is the version 5 actually. These are the major 3 criteria, major impact categories, like I said. Decarbonization. Decarbonization, you can see, let's say, this is MRC5, construction and demolition waste diversion. So that focuses on that, the impact of that criteria is on the decarbonization. And the second one, you can see there's a resilience spaces. Resilience spaces support quality of life. So likewise, they have like identified different criteria and what they support, the impact category. And you can, I told you, even though there are 8 criteria or 7 criteria, the point allocation is not same. And what the major allocation is for in the lead? You can see here. This is EA. EA means, can I see hands those who are awake? Okay, what is EA? EA, energy and atmosphere, right? Okay. Okay, that timing. Okay, any questions up to now? Any questions, clarifications? So if it is all clear, can I see hands? All clear? So, okay, easy question. So what is the rating system that we are discussing right now? Those who know the answer, can I see hands? What is the rating system that is being discussed right now? Can I hear the answer? I can't hear. Lead. And what is the version? Sorry? Version 5. Okay. Okay, so this is about lead. And now we are discussing bit about the green mark, that is the Singapore rating system. Have you heard the green mark rating system, about the green mark? Okay. Let's do before going into next. I hope everyone has the phone, your mobile phone with you. Okay, I'll give you a little exercise. Just search green mark and find the meanings of these terms. What is EE? What is IN? What is HW? I want answers. Okay. If you found the answer, just raise your hand. Okay. Okay, got it. Doesn't take time. We can use artificial intelligence. Okay. What is EE? Sorry? Energy efficiency. IN? Sorry? Indo? Intelligence. I can hear two answers. What is IN? I'm asking about the green mark. Okay. IN has a separate identity for maybe green SL. IN means innovation. So what is IN in green mark? Innovation. Intelligence. Okay. HW? Health and well-being. CN? Huh? Carbon. MT? Maintainability. RE? Sorry? Resilience. Okay. EE means energy efficiency. IN intelligence. HW health and well-being. Carbon. Whole life carbon is EN. Maintainability MT. RE means resilience. Like I said, their rating system have like aligned with the SDGs, like Sustainable Development Goals. So this is a very good rating system actually, because Singapore is a country like us, a tropical country, and their rating system focuses on just not just like point based system. The energy efficiency is a must have. They have three major parts to go through, like pathways. If it is energy efficient, like if there are benchmarks, if they pass that benchmark, only they can go along the rest of the section. So this is a very good rating system, and there are guidelines available in the internet also. Just feel free to refer. Okay, now this is our rating system. Green Building Council of Sri Lanka is the organization under the World Green Building Council. It's a member of World Green Building Council, and this is the rating system developed by them. And they have 8 major criteria. So you like starting from management, MN, then sustainable sites, water efficiency, energy efficiency, material resources and waste management, indoor environmental quality, innovation, and social and cultural awareness. So those are the 8 criteria in the Green SL rating system. So like I said, the weightage given for Sri Lankan rating system is like this. And you can see the major component still goes to sustainable sites. That's 25. Like 25% of the marks are for sustainable sites. And the second highest component is energy. So we focus more on, we are also uh, um, the challenges are there for energy. So we have 22% of the rating system for energy, and then 14% for water and materials, 13% for indoor environmental quality, and 4 points under 3 sections: management, innovation, social and cultural awareness. Okay, so like I mentioned earlier, there are mandatory provisions as well as credits. So green in a green rating system, this is the basic structure. This is applicable for many rating systems. We have main categories, like I mentioned, the 8 or 7 major categories, and there are prerequisites as well as credits. So prerequisites mean those are mandatory provisions under each category, and without complying that, we can't gather the credits under each section. And each part, like for example, let's say under sustainable sites, we have to have heat island effect on land. So under that, there's an intent. Under each criteria, there's an intent, there's a requirement, as well as the number of points, or if it is mandatory, that is there under each criteria. So it is mentioned the intent, what is the intent behind having that, why we are focusing on this certain credit, and then what is the requirement to achieve that, what should we do, and what are the points that we can get if we comply this. So everything is there in a green building rating system. And if we collect all the points along the framework, if we can collect over 40 points, if it is a certified, 40 to 49, and 50 to 59 means it's a silver rated green building. 60 to 69 is a gold certified green building, and over 70 it becomes a platinum rated green building. So this is according to green SR rating system. But in LEED, to get a platinum, what is the point, how many points you should take, you should collect? LEED, how many points to get platinum? We need 80 points. We need to collect 80 points to make it platinum. Okay, for green SL still it is 70. Okay, 3 criteria. So let's have a quick look at the what are the criteria in all the. This is a common one, not specifically focusing on a rating tool, but energy efficiency, water efficiency. So these are the criteria that I mentioned earlier also. So can I hear? Can you read this out? The criteria names from the behind. What is the first one? Energy efficiency. Then water conservation, indoor environmental quality, materials and resources, innovation. Okay, so these are the basic criteria among most of the sections. So let's focus on lead. They have a separate one for location and transport. So they focus on how a building is located. They are giving, they are assessing a building according to the location as well as how the transportation is arranged for building. So this is an example that explains different criteria in the rating system. This is according to LEED. Okay. The first one, sensitive land protection. Um, yeah, sensitive land protection. So we need to protect and preserve the existing building. So when we construct a building from the design stage or from the thought of designing a building, we have to focus on the location where the project site is located, whether it is below the flood level or whether it is near to a wildlife, maybe a forest. So likewise, we have to do a certain study before starting construction. Of course, we have to get certain approvals. Then to become a like to before even applying to a green rating system, maybe LEED or maybe green SL, we should definitely get the local authorities approvals. That building should have those approvals before applying to green certification. And definitely we need to ensure that the site, the location is not situated near to a wildlife. Likewise, there are certain conditions we have to ensure, that ensures we are not damaging the environment and the surrounding habitats are protected. Then you can see the transport, that is the location wise it is okay now. Then how about a building? I'm asking a question. How about a building? One option is to locate that building in a urban area, uh, and the second option is to locate the building in a rural area, maybe uh, like 50 100 200 kilometers away from major city center. So but it is constructed in a very environmental friendly way. But what is the best building, which is better, to locate in the urban or locate in a rural? Option A, those who say A, urban. Those who say rural, to locate the building in a rural area, it is the more sustainable way. A or B? A, urban කියනයි බලන්න. Okay, rural, to locate the building in rural. Okay, I think you got the point. Uh, if the building is located in rural, what happens is we have to travel a lot, right? Transport related emissions gets high because of the building located in a rural area that the people have to travel a lot. Then it doesn't support the triple P, right? So that's why location and transport has become a major component in a rating system. So the building should support public transport. They should have the public transport access as well as environmental friendly transportation infrastructure should be there, like cycling parking facilities, as well as electric vehicle charging facilities. So that means if there is a charging facility, so those who have the electric vehicles, especially these days, they tend to travel using electric vehicles. So that support, because of the building, that support the environment. And the compact and connected development is also another one. If it is developed in a urban area, and there are two options again. And let's say we have the same area, like 2 acres in land, in urban area and rural area, and we design, uh, sorry, not urban and rural, the same, there's a land. One option is to build 4-story building, and the second option is to building like single story but using many land area. So what is the best option? High rise or low rise? High rise? Okay. Low rise? Yeah. So it is important to go to high rise, because then it is compacted development. So that's why, if it is, especially if it is in the urban area, then it reduces the it reduces the disturbance to the natural environment, because we use certain limited area, and we can go higher. So that's the compact development. Okay, so I explained this compact development density, again community connectivity. So if it is located in an urban space, then we need certain facilities. So let's say it's a house, like apartment building. The people need a police station, a school, maybe what are the temples, banks. All the facilities are essential when we live, right? So if it is located in urban space, urban area, then in a community which has the easy access, then it's very sustainable, and it reduces the travel and accessible easily. Okay, let's quickly go through site management. That's the second one. Sustainable sites in local rating system has 25% of the points for sustainable sites, and it considers the accessible outdoor spaces. That's where the greenery aspect is considered, how the waste, or how the hydrology is managed within the site, like the heat island reduction, the cool roofs. So you may have seen the parking lots with greenery, green pavings. Have you seen? So have you ever wondered why we are going for that? How it supports for the sustainable sites part? I am talking about, sorry, I have that photo, I show you. So that greenery paving supports heat island reduction. Heat island effect means, do you know, have you heard the heat island effect? And have, just imagine, you may have traveled maybe through a bike or some, especially when you travel in a bike, you feel, um, let's say from urban area to a rural area where there are a lot of trees and all, you feel a temperature difference, right? When we go along the road. So why? Because in the urban area there are a lot of concrete structures, right? But in like urban area, they have a lot of trees and they absorb heat. But the concrete structures, what it does is they reflect the heat, or absorb heat, and infrared radiation is there, and the surrounding temperature goes high. It's like when you sorry, if this is urban area, lot of buildings and there are trees, this is the rural area. If we say the temperature profile, it is something like this. So this area the temperature is higher, this area it's low. So this is the heat island effect. And to support that, to minimize the heat island effect, we can use different components. Like we can use the greenery. Again, greenery supports a lot to reduce the heat island effect. And if you are using if you want to use the paving, we have one option to use the greenery paving. Otherwise, there are certain colors which reduces the heat island effect. We call the property of the material called SRI, solar reflectance index. So there are certain numbers we have to allocate to reduce the heat island effect when we are selecting materials. So in a green building, to support to reduce the heat island effect, there are certain criteria developed when we are selecting paving material. So just you will be going for a site visit also. Then you can look at the paving materials. You can ask about that from the person who will walk you through about the paving materials that you have used. So what is the solar reflectance index? So likewise, you can ask questions. So those are the green building elements that we use to reduce the heat island effect. And again, there are paints available, the light color paints. This is very, I think, fundamental principle. If a building has a dark color, maybe black and white, if we say, the black color absorbs heat a lot, right? We have learned it in schools also. So the white color reflects, but not absorb. So again, it supports the heat island effect. Then the sustainable sites also look at how the light. The another important one is the rainwater management. Then we should control the rainwater, the pollution site solar. Sorry. Rainwater is properly managed without eroding the soil in the site. And another the feature that I am talking about, the paving materials, if it is greenery, they absorb water into the ground without having a runoff, right? So that supports the rainwater management. And then biodiverse habitats. Then another important and very not that popular one is the light pollution reduction. Do you know what light pollution? Okay, okay, let's discuss. So let's go one by one. In the sustainable sites, we are supposed to minimize the site disturbance from the construction as well as when the operation stage. When we are doing the construction, we have to ensure that the sedimentation and erosion control practices are there. So that's why these kind of sill traps and all the I'll show you other practices. So we have to control the even washing bays. You may have seen washing bays. So there are a lot of trucks and all the vehicles come and go to a site, construction site. When they go along the site, they can carry soil throughout the road, right? And they use the washing bays to wash the tires before they send it out, so that they ensure that the soil and erosion control is properly taken care. So just imagine if the truck is going like 100 times and it carries certain soil, then it's a huge uh, erosion. So silt traps, drains, and properly the even through the construction stage, they have to ensure that the water management practices are there, and the soil and erosion control is a mandatory provision in Sri Lankan rating system also. And especially if the site is located nearby a water stream or something like that, we should have these type of practices. Actually, the slides, these slides are from I should give the credit to Melanie Tilakaratne. So these are the practices that we can allocate in a site. And again, for the soil and erosion control practices, these are so we can have the greenery within the site. so that the embankments are protected. And as much as possible, we have to protect the existing trees. And this is the stormwater management. Uh, we should have a good drainage facility within the site, like I said, throughout the construction as well as operation stage. This is the greenery paving I was talking about. Okay, so when we say a green building, this is the major element that comes to our mind. So let's see why it is that important. How does a green facade or a green wall or this greenery feature support the building? The major one is the heat gain. They control the heat gain. So you can see there are research done, and the first one, there is no greenery. This is just concrete space, and then there's a certain greenery or vegetation there, and this is the thickness of the vegetation is bit higher, and you can see the temperature profiles. The surface temperature is really high in the first one, and it reduces when there's a greenery. That's obvious. That means if the surface temperature is controlled, that means the heat gain inside the building is also reduced. What happens when the heat gain is reduced? Cooling load. Cooling load on the HVAC system reduces, right? That means it is good for the pocket. Okay, so light pollution reduction is another component in under the sustainable sites. So sustainable sites part focuses on, or the intent of that entire criteria is the we have to ensure the ecological practices, like we have to support the nature basically. So light pollution reduction ensures night features, the nightlife features are protected, or access to night light is protected with the lighting facilities in the building. So there are options for the lighting, and you can see the access to night light, visibility of the night light, night sky when we are using different types of fixtures. So what happens? And you may have seen the access to night sky is very limited in urban space, but when we are going along rural area, we can see even stars. So that means we are not disturbing the night features when we are using this type of fixtures. Okay, time flies. Moving into the energy and atmosphere, this is another important and the most important section of the rating system, I would say. This ensures there are a lot of reading parts. You can read leisurely. I'm distributing the slides with you. So basically, it says operational, and there are again mandatory provisions as well as credit related provisions. So this is according to leads. Now we have to ensure the building has a low carbon footprint, and it is planned to reduce the carbon footprint. And we have to ensure minimum energy efficiency is there, and we have to do the commissioning. So let's go one by one. Again, these slides are also from the Melody Tilakaratna. Energy efficiency. This is actually when we design a building for the energy efficiency. Have you heard the term building envelope? What is envelope? Building envelope. What are the components that falls under a building envelope? Let's say this is a building. We have the outer structure. We have a roof, we have walls, and we have floors and doors and windows. So basically, this is the building envelope. So in terms of green building, to reduce the energy load, or to become it energy efficient, we have to design this building envelope properly, because that is how we gain the heat inside the to reduce the heat gain inside the building. So we should have proper insulation, high performance glazing, and heat reflective components. And even through orientation in the design stage, we can locate the building and locate the windows, and when we are placing the doors and windows in the building, we can ensure that we can take the sun path and locate those, so that the sun rays are not directly facing. And the shading devices, those are again that supports the energy efficiency of the building. Okay, so there are again green rating system, that is not only like one document, that can engage different other rating, other standards as well. So ASHRAE is another one. ASHRAE is a rate, not a rating system, this is a standard that we can use to design the building. Okay, so energy efficiency, in the energy efficiency component, we use this type of whole building energy simulation. Especially if the building is going for a certification, we have to model that building and simulate and show how energy efficient the building is. And the softwares, or the energy simulation softwares that we can use are eQuest. eQuest is it is freely available. Even if you can try eQuest, Design Builder, HAP, IES. There are several platforms that you can use for energy simulation. And I would say, if you focus on your career in this aspect, uh, I don't know about others, but I experienced that there are very limited professionals who are practicing these platforms. So if you can master that, you can earn. Even I would recruit some of you. Okay, so these are some sample from the simulation output. So what basically doing is, for green rating system means we are doing verification, right? To verify that, just looking at the building, we can't say that yes, this is energy efficient. We can't say. But if we do the design to a simulation and see, yes, these are the materials that we have used, and this is a simulation result, and this shows this type of uh, the consumption profile, then we can decide whether this is actually energy efficient building. And the building commissioning is another part. Commissioning means, what does the commission do? Building commissioning ensure, yes, there are designers involved, MEP engineers involved. But after designing a building, we have to, like, it's kind of a tune up. We have to ensure the building is performing design, according to the design. It's kind of a tuning of the building. Like, let's say a guitar, we can't just get a guitar and play. We have to tune it up, right? So as same way, in a building, we have to tune that to perform as the design. So that's what a commission do. Okay, refrigerant management is another major component under the energy and atmosphere part. What are refrigerants? Where do we use refrigerant? Sorry, refrigerants. Uh, so major component of, like, from the building, like 50% of the energy consumption is going for the HVAC system generally. Okay, and the HVAC systems use refrigerants. AC gases. What are the AC gas types? commonly available gas types. R, it starts with R normally. R32, R134A, R410A. Likewise, you may have seen different types of AC gas types. And R22 is also there, but it is phasing out because they are because of one reason. You may have heard R22 also. It's a AC gas type, and we have to phase out as a global policy. We can't use R22 after 2030 because we call ODP and GWP. GWP means global warming potential, and ODP means ozone depletion potential. So all the refrigerant types, there are numbers. We have to look at the ODP and GWP values before selecting. Like I'm not sure about R22. Yes, HCFC 22 means R22. You can see what is the GWP? 1780. And 32, it's not there, but 134A 1320. So likewise, but HCFC 22 has ODP also 0.05. Ozone depletion potential mean it has what is the potential of destroying the ozone layer. Impact on ozone layer is determined by the ODP. Global warming potential means you may have heard greenhouse gases. So greenhouse gases means the potential of greenhouse gases absorb heat and emit to the atmosphere. That's how our planet has become a livable planet, because we have an atmosphere, and the atmosphere also has greenhouse gases. And these refrigerants, some of the refrigerants are also they also are greenhouse gases, and that's why they have a global warming potential. So we have to ensure that the gases that we use in our buildings have a low global warming potential and ozone depletion potential. That's why refrigerant management is important. In use stage, we have to ensure these are properly managed, like properly in my experience also, there are buildings, they don't do the services properly, and when we are doing the carbon footprint calculation, we have to count that what is the number of kilograms replaced or top up quantity of the refrigerant gases in the building. And at one point we realized there was a building, there's a huge leak, and they haven't noticed it, but they have doing the top up and all, and after doing the assessment they could save. But what about, they saved money, but environmental wise they have done a major impact on the environment, because they have refrigerant gases have a huge global warming potential. So this is compared to carbon dioxide. Carbon dioxide has only one, but HCFC 22 has 1780 global warming potential. Okay, the next one in the energy and atmosphere part is renewable energy. So now it's becoming a very major component in building design. So renewable energy, when we say renewable energy, is it only solar? Is it only solar? Solar is the major one, and now it is a cost effective one. But there are other renewable energy components as well, like wind turbines. So we can use the wind energy, and basically some other countries geothermal heat pumps are also there. But for Sri Lanka, the main renewable energy sources are solar and wind. And if for buildings, major source is solar. Okay, the next one, let's quickly go. Water metering. So in water, when we look at the water consumption of the building, we have to ensure that the water consumption is reduced, like efficiency is improved, and we have to do the proper monitoring to detect whether it is using the correct way. Sometimes, uh, most of the cases in Sri Lanka, I would say, they design the building and they get certification, and after that, that's gone. After 2 years, if we go and see, there's nothing. And earlier they had sensor tabs and all the things, but after 2 years, none. And if we ask the consumption of the total water consumption of the building, they don't know. So that means we can design buildings according to principles, but we have to ensure that the buildings are properly managed according to the design. So that's why the energy metering and reporting is important. We have to ensure that the fixtures are properly working and whether they are efficient, and then minimum water efficiency part ensures that the correct fixtures are involved, and water metering and leak detections are also very important in buildings to detect leak. Sometimes when we neglect a leak, it can consume like tons of like mm, if it is, especially if it is a pool, it is a huge amount of water that we lose, and it finally ends up a lot of money. Okay, under water efficiency, the landscaping wise, so green building means we engage a lot of greenery in the building, right? But to maintain the greenery, what do we need? We need to water the plants. That means we need a lot of water. So, but when we engage the water efficient landscaping practices, like we can use the native plants. So if we get plants from the newer area and plant it in Colombo, then what happens? It is not effective, right? It doesn't survive. But if we engage the plants that is well grown in the within the region, then actually we don't need to maintain a lot, and it needs minimum amount of water also. That's how the planting practices or landscaping practices support water efficiency in a building. And then rainwater harvesting is another principle that we can use in a green building. So that reduces what? Rainwater harvesting reduces uh, the pressure on main water like treated water consumption. So we can get easily the national line with water from the national line and plant the water. So what happens? Do you know how much it costs to treat 1 cubic meter of water? It uses lot of energy, right? Uses lot of energy and resources, and it is in the drinkable quality. It is a disaster to use the drinkable quality water to plants, and we 90% of the water that we consume goes as waste wastewater. But if we can treat the water and use for the landscaping purpose, then that's the most sustainable way. So that's why in green buildings, wastewater management is also one major part. Uh, Not only the water efficient practices, but also the wastewater management. Okay, I will not read this out, but these are the baseline consumption when we are looking at the water efficient fixtures. Water closets, it's like 6 liters per flush. So generally, if it is more than 6, then that is not water efficient fixture. For urinals, it's like 3.8 liters per flush. Public lavatory faucet, 1.9 liters per minute. So likewise, there are thresholds developed for green rating system, but these numbers are based on the ASHRAE guidelines, and with the guideline development, with the guideline updates, these numbers might change. Okay, materials. So materials and resources are also very important, especially in the construction stage. So construction stage wise, we have to ensure that the first, if the land is a reused one, like there was an existing building and we are doing a construction, as much as possible we have to reuse the space. We have to reuse the space if it is possible, and also we can consider reusing the used materials. And first in the case, ensure the space is designed only for the requirement. Just imagine how the houses are built in Sri Lanka. There are only 3 people, but they have like five, 6 bedrooms per house, thinking about never coming future. So how much cost it takes for the materials and the energy. So that's why, especially in the materials and resources, we have to design the space properly, and then we can reuse the materials as much as possible. And when we are doing the construction, we have to ensure the waste is properly managed, and we can use the circular economy practices, and that means reduce the pressure on the virgin materials. And when we select materials also, there are many variety of options. Let's say paints, there are number of paints in the market. But when you are going for a certification, especially green building certification, we can look at their certifications in the materials also. Environmental Product Declaration, EPD. We can look at whether they have an EPD. That means their profile, like kind of a passport, material passport. So that means um, the EPD showcase per unit what is the carbon emission of this material, like embodied energy, embodied carbon. So this verifies that uh, the properties in that material. And have you heard the green label materials, green label products? Can you name few green label product in the market? Let's say cement. I'm not marketing here, okay? But there are green label products for cements, for I won't mention the names, otherwise it is kind of marketing. But uh, there are paints, even water fixtures. They have got the green label from the Green Building Council. They have separate separate scheme for green labeling process. And globally wise, there are different schemes that they verify the materials. The EPD is one certificate, and there are eco labels in different organizations. So we can look at those when we select materials. And another major component in the material profiles we have to look at, but it is more relevant to the IEQ section, VOC, volatile organic compound. So we'll discuss in next section. Okay, construction waste management hierarchy is like this. So like I said, we have to reduce the construction area first, then reuse, recycling, recover, disposal. So that's the best. That's how we should go. We have to reduce as much as possible. Then we have to see whether we can reuse. So this is example for reusing the waste materials. Sorry, this one. And the waste is properly managed within the sites. Uh, they are reusing the materials, and these are the certified products I was talking about. If especially the timber, and there are other materials also that they can get they have the certifications. And sustainable building systems. Now you may have heard this. Now I think I have seen this only in ICC. they are using a technique like they directly get blocks and do the construction very quickly. So they use that technology, and there are wall panels without using brick by brick. They have the panels developed, and they just, it's like building blocks. So that reduces time and reduces waste, and very time the time is saved. Time saving means energy saving. So those are the sustainable practices that we can use under material and resource efficient section. Okay, this is one example of impact of material selection on urban surface temperatures and the urban heat island effect. So that's basically the impact of having greenery on the roof. Can you see the difference? The heat. Okay. So far, any questions? I know it's a lot, but unfortunately, I have to cover all the parts. IEQ. So when we say IEQ, indoor environmental quality. So it's not only about air. What are the other components? So when we say indoor environmental quality, it's not. It's about air quality and lighting, thermal comfort, and also the acoustic performance. All the things are together taken. It's called indoor environmental quality. So under the indoor environmental quality, that's where this is one component under that we have to use low emitting materials. Low emitting materials means that's where okay, just one example. You may have felt when we enter to a newly painted space, kind of smell. Have you felt? Why do we feel that? What's the component that causes that? Or else a closed auditorium, from the furniture that we can get a smell, right? Have you felt from the carpets, the carpet where there are a lot of carpets involved? When we are entering the closed space, we get. So that's because of the VOCs, volatile organic compounds. So in a furniture, we use different paints and coatings. In the carpets, the material has uh, again the rubber and all. They have the volatile organic compounds in the property in the material. So when it is with the heat and all, they react and they can emit into the atmosphere, which is not good for your health, people's health. So in a green building, it is we have to ensure when we select those materials, look at we have to look at the VOC levels of that material. That's why we have to ensure the green label products. They ensure that if the material is green labeled or green certified, then it says that this is according to the standards, the VOC levels are taken care. Then we don't have to worry. Otherwise, we have to look at the VOCs especially when we select paints, coatings, and the carpets. Okay, so this is about the thermal comfort. So I'm not going to explain in detail, but when we are designing spaces, we have to ensure the temperature, the thermal comfort is maintained. So ASHRAE guidelines are followed when we are designing the thermal comfort levels of the building. So this is uh, uh, the comfort zone that is appropriate. So the temperature levels as well as the RH. So those are the main two components we have to ensure when the building has the proper thermal comfort. But there are four other elements that support thermal comfort. What are those? Temperature, relative humidity, that is RH, even clothing, the clothing that we wear, air velocity. So likewise, there are six criteria when we are determining the thermal comfort. But when we are designing the building, the main two components we have to ensure is the temperature and RH. Okay, so the daylight and views, another two components. So when we design the spaces, we can use this type of window spaces, windows, so that the daylighting can be harvested, so that the lighting requirement is reduced. Sometimes we can I would say, if we retrofit this area, we can use sensors, daylight sensors, near the windows, and it ensures that there's a certain lux levels in this space. This is automatically switched off. So that's how the building is improved and reduce the energy consumption. Okay, so that is the energy part. But under indoor environmental quality, daylight and views are two other components we can engage. Daylight harvesting and uh, access to outdoor environment. So just imagine, you may have been in spaces where you can't see outdoor environment, just the four walls. What do you feel? I think mostly exam halls are like that. No outdoor access. Anyway, we are stressed in a exam hall, and if it is outdoor access is not there, more stressed, because that's the human nature. So we are bound to the nature, and it's research, by research it is proven we have a huge very close connection to the environment. And if we can see the environment, we have the access to the outdoor environment, it affects our mentality. So like I said, green building supports all the three pillars, the triple P. So people part, this daylight harvesting and access to views is important. So that's why a lot of green buildings, a lot of glasses are involved. Okay, controllability of light. So that's where I told the sensors. If the daylight harvesting is there, the lights can be switched off. And the switching also, there are some spaces when we switch on, entire space is lighted. But just imagine if we are using only this space, uh, these lights are a waste, right? But if there are individual switches, then we can switch off those and use this area. So that's the controllability of lighting. And we can engage, like I said, the sensors also. Okay, so this is the VOC I was talking about. Okay, so Dulux, there are brands, and VOC limits are listed here. You can see, generally it should be below, as I remember, it should be below 50. I can't remember the number exactly, but the rating system has mentioned what is the VOC limit that should be there in the materials. Okay, okay. Innovation. Innovation is also a component in the rating system. So that's basically, uh, again, as the name it says, how innovative the structure is, how the design is supporting their energy performance or whatever it is in a very innovative manner. So that's very unique. I would show you, I am showing few examples here. There are few buildings, um, we call this biomimicry. It's kind of, we can use biomimicry for innovative innovation in buildings. So this is estate centered, and this building is inspired from a termite mound. The ventilation system is uh, supporting from termite mound. So natural ventilation is there, and it uses like, the energy reduction is like 10% of energy is conventional. This is another one, Singapore Art Center, which is inspired from the durian fruit. So this is the outer layer of the structure, and the real building is inside that. So like dual facade system supports the reduces the heat gain inside the habitable spaces. And this is another one, Eden Project Biomes. It is inspired from the soap bubble. And the amount of material, this is a very thin material, but durable and strong. So that reduces the amount of materials that is used for the structure. So the material reduction means it's a huge saving. Okay, community integration is the last part. The community aspect is taken care with support of other credits as well. But for green SS rating system, there's a social and cultural awareness section separately for community integration and well-being. So we can develop spaces not only for like energy saving and water saving and all, but to support the mental health, physical health, the safety of the people. So ensuring all, we can make the building in a very livable space. Okay, the most interesting part is this, the case studies. Can I take few minutes? I would say actually I started my career as a civil engineer, okay, but I'm really grateful for my first job. It was civil and structural engineering consultants private limited, and I was working under engineer Shiromal Fernando, and it's because of him I got inspired to green buildings, because the first task I was given to read green building related books, because he was the vice chairman of the Green Building Council. So the task I was given was uh, read the green building related books and summarize to him. And it was really interesting. And there are the books that I was given are like this size. And when we look at the pictures and when I read, I got really interesting. And if you are interested in a certain subject, not only green building, but if you have separate interest, just go and refer the case studies, I would say. If you are, there may be geotechnical students and I don't know, environmental technology and all. Whatever the career that you are going forward, just go and refer the case studies. That's the best way to inspire as well as learn. Okay, so there's another video, and I would say the Crystal London and Bullet Center Seattle. Those are like major green buildings, like well-performing buildings in the world. And the below ones, these are not new construction one, but retrofitted existing buildings converted into green buildings. Okay, only few more slides. I'll quickly go. This is a building in Singapore. Okay, I'll show you the video how the different features are embedded in a building, a case study.
Communications and Multimedia Commission, MCMC Tower 1. This 22-story building was built with the characteristics of a green building. To continue the commitment on sustainable development and green building initiatives, much efforts have been put in assuring better use of resources while reducing building impact on human health and the environment during the building's life cycle. Major green features incorporated in the building design include use of low E glass facade to reduce indoor heat gain and allow natural day lighting. Solar panels located at the rooftop with a maximum capacity of 60 kilowatts per hour. Wind turbine that is capable of harvesting wind at a maximum capacity of 5 kilowatts per hour. Energy efficient light fittings to provide up to 15% more light output for the same wattage. Incorporation of rainwater harvesting and grey water recycling systems to enable saving of potable water consumption. Fitting out of the interior finishes, including furniture, which are made of recyclable materials. Rooftop garden that was designed to reduce the building's thermal load, which in turn reduces the temperature inside the building. Green building benefits go beyond economics and the environment. MCMC strengthens its commitment to sustain and improve the quality of human life and its surrounding environment, setting new standards.
Okay. So that's how different components are embedded in a building in a practical way, and you will see in the site visit as well. Okay, for a few Sri Lankan case studies. What is this? Have you been there? Do you identify the building? Hotel? Heritage Kandalam. Okay, this is, you can see the name. This is in Colombo, Iceland Business Center. This is both Green SL and LEED certified. LEED Platinum, and I think Sri Lanka Green SL also Platinum now. Have you seen this? Clear Point Residencies, Rajagiri. This is, I think, the highest rated building in Green SL rating system. 98 points. Have you been there? Denta Factory. Paduk. Oceanfront Condos Gold. This is apartment complex. Again, Green SL Platinum. This is a hospital, pediatric ward complex, Ampara. Again, Green SL Platinum rated building. Okay, if you and you are visiting the Parkland building in Colombo, it's also Green SL Platinum rated building. Okay, the last section, few more, 4 slides. Advancing net zero. So this is actually, I would say, the most important part, because this is where the world is going. Advancing net zero project means we are targeting to net zero. By 2030, all buildings must operate net zero, and 2050, all the embodied and operation carbon should be net zero. That means the whole life carbon vision. And when we design the building, we can plan the beyond, like the end of the life of the building as well, so that prefabrication and modular construction can be used and designed for disassembly and recovery. Means at the demolition stage, it's only disassembling the building, so no dust and no demolition involved. Circular economy in construction. Again, we have to use the materials again and again, so that the pressure on the virgin materials are reduced. And I am giving you a reference. If you are wondering about the material passports and material profiles, you can refer to this site, and it has the 2050 materials. Means it has the material profiles in different components, like it has paints, it has wall materials, all the things. Biophilic design, we can engage. You can see the first image. This space is in the building. So biophilic design is a really important feature when we are designing a green building. And mixed use development is another trending concept, because um, it has all the shopping malls and hospitals and all the housing units, so that transportation between buildings are reduced. So that is also a support, the very sustainable concept. And of course, innovation, AI integration, all the things are coming norm to the building industry as well. Okay, final slide. This is the summary. So these are 5 points. We have to ensure the green buildings. This is not only an add-on, it's but we have to ensure that from the design or concept stage, the certain principles are followed. Not after constructing, we are not converting it to a green building. It's from the beginning. And embodied carbon matters as much as the operation carbon. That's where we ensure the how the when we are selecting materials, embodied carbon should be minimal. And rating systems, that's the main part we discussed today. Rating systems means it's a guiding document as well as it shows us the benchmarks. And tropical climate in a country like Sri Lanka, using the passive strategies like daylight harvesting and natural ventilation, those concepts are really important. Okay, the last point is about the career pathways. You can get the accreditation early and involve in credible green building pathways, starting from maybe lead green associate or Sri Lankan rating system green SL associate. So that's the end. Questions? If you have questions, time. Ah, GP passes. Okay, I was talking about the career pathways, and when we talk about career pathways, and I skipped my introduction slide, so I'll do that part. Okay, okay, so I have started a company called Hive. So regarding uh, career guidance, I have the network. I have formed a Green Future Network. Have you heard that before? Have you attended our webinars by any chance? Those who have heard Green Future Network, can I see hands? Okay, that's fine. That's totally fine. I started it in like 6 months back, 8 months back. Now it has a certain community. What we are doing is we guide like students like you for sustainability related careers. We provide the mentoring, and we have monthly sessions also. From the industry expert, we get industry experts and uh, allow you to engage with the expert and get what the career insights. So likewise, that's why I wanted you to know green building related careers as well. If you are interested in green building related careers, start it from associate level. So there are, for Sri Lanka, it's Green Building Council. But if you are interested in international one, you can get the lead green associate. So I'm still lead green associate, but Sri Lankan, I have got the accreditation as the green SL accredited professional. So that's the pathway in this one. So when, this is just a small advice when you are studying not only this subject but others. Always just don't study or don't attend lectures just to pass the exam. Just go, just refer to the lectures and see why we are learning. Always focus on your why we are learning this module, why this university has entered this module in your degree, because we are studying for a career, right? So look at that career value and always look at it in not only in the Sri Lankan context but also internationally. So if you are looking at geotechnology, don't study only for Sri Lankan context, but study about the geotechnical aspect in other countries as well, because this is a global, now it is interconnected world, right? Even though we are in Sri Lanka, in island, we have to deal with other countries. So always be ready for that global citizen. Okay, that's all.
Appreciate your time and valuable experience. As a small token of immense gratitude for your presence and for your sharing knowledge today, we would like to present to you with a token of appreciation. To do the honors, I would like to invite Dr. Manori Pereira, and I would also invite Engineer Upeksha to the stage. Um, Now, behind every success of an every event, there's a team working tirelessly behind the scenes. To express gratitude to everyone who made this day possible, I would now like to invite CETSS executive member, Ms. Chetana Dilakshiti, to deliver the vote of thanks.
I would like to take few moments to express our sincere gratitude to everyone who contributed to success of this event. First, our heartfelt thank to our guest speaker, Engineer Upeksha Virajini, for sharing her valuable knowledge and experience with inspiring insight with us. And also, our sincerely thanks, our special note of appreciation goes to our Mr. Manori Pereira to conduct continuous guidance, encouragement to support this event. And also, our sincere thanks also go to the head of department, Dr. Sakura Bogoda, Civil and Environmental Technology Society, Department of Faculty of Technology, and our respective gratitude to our CETS Society advisor, Dr. Darshika Vanigaratna, to support this successive session. I would like to thank for all organizing members of CETS Society and also our videography team and everyone behind this scene. Finally, a big thank you to, of course, for every participant, every lectures and demonstrators, and every participant students who are joined with us virtually and also physically. Actually, your active participation made today's session more interactive. So, once again, thank you for everyone. Have a nice day.
Chetana, everyone, this brings the end to our session. We hope you leave this room inspired to build a greener, cleaner, and a more sustainable tomorrow. Um, a big thanks to everyone, both in venue and those who joined us online, for the active participation and the support. Thank you all, and we will surely meet again in an event like this in the future. And have a wonderful evening. But before we officially part ways, I would like to invite our guest lecturer and all the members to the front to for a group photo to capture the memories made in this wonderful day.